This is the first part of a three-part series where we'll add more GPIO output pins to the serve RISC-V processor that's in the FPGA fabric of a Polar Fire FPGA on the BeagleV Fire development board. The first part, we'll dig through with Libero, and figure out how those I/O pins are wired. The second part, we will modify the serve RTL Verilog. And in the final part, we'll write some C code that runs on the serve processor and controls those GPIO pins. I think that's about it. Let's get started. Okay, the first thing we want to do is track down what pins of the FPGA are connected to the LEDs. Good place to start is with the documentation. Right here, the pinout diagrams. Go to this, and this shows you that this P8 connector also has connected to those same pins, LED 3, 4, 5, 6, all the way up to 14. So it looks like there is up to 12 LEDs, and they're connected to these signal names on the FPGA in red and these pin numbers on the FPGA in blue. So that gives us a big answer. We're going to do it slightly different because this documentation is sometimes not right. In fact, I would go so far as to say, never trust documentation. I haven't found anything wrong with the BeagleBoard documentation yet, but good rule for me, never trust documentation or comments. So what we're going to do is actually dig into the schematic and see if this is correct. So here's how I would do it. First of all, go to the schematic. Here's the link. Searchable. You can search for LEDs. You find that there is LED 3 through 14, which lines up with the documentation, and it's connected to these pins 3 through 14. And what I tend to do is build myself a little table, a little spreadsheet. And so I'll do some fast forwarding through this one, but here we're going to build a spreadsheet. LED, let's see, Control C. Okay, and now we're going to search for some of these pins, and let's pick this one here, and let's search for it and see where it goes. Control F, Control F, Control V. Here it is. And so it goes to the BeagleBoard header. We already knew that. So let's keep looking. So this looks like pin 14 goes to B9 and pin 13 goes to B10. So let's write that down. 13 goes to B10 and 14 goes to B9. All right. Let's see how close we are in the documentation here. It says here that 14 goes to B9 and 13 goes to B10. So good job, documentators. Let's keep digging. Let's see if there's any issues with these pins. So let's look for LED 12. So let's back to the schematic. So this pin goes to, instead of going directly to the FPGA, it goes to a level shifter. The level shifter has a cool ability that on the A side, look at VCCA, that goes to 1.8 volts. So all these signals are in the 1.8 volt domain, which is coming from the FPGA. Then it goes through here, and you can see VCCB, which is associated with all these B signals, and that's going to 3.3 volts. So all this side, the the P8 header and the LEDs are getting driven by 3.3 volts. So that's what this level shifter is doing. So we are going to go and track across this guy. So this is an interesting name conversion right here. Let's see. So let's minimize him again, or shrink him. And so we've got 15 and 16 we don't care about. We don't care about these. We slide across. We've got P6, P5, okay. So we've figured out all these pins. Let's go and take these two here. Okay, now we've got all the pins identified. Now let's go back and see how the rest of these matched up. So we've got LED 3 goes to V22, LED 3 goes to V22. Nice. 4 goes to W22, W22. Nice. 5 goes to V19, V19. 6 goes to V20, 6 goes to V20. 7 is V15 right here. 8 is V14. Nice. 9 is V21, V21. 10 is W12. I mean, W21. Yes. Okay. 11 is Y21. 11 is Y21. And 12 is Y20. 12 is Y20. And we've already confirmed the bottom two. So nice job. I approve of this document. So that's what you do in a schematic review, or you should do, to make sure that the schematic matches the documentation. These reviews are not always done. Looks like the BeagleV Fire team did a good job. Check mark. All right, so I'm going to keep this because that was a nice, useful document for me. All right, next up, let's dive into Libero and see how these signals are wired up internally to the FPGA. Okay, so now we know how to map all those pins to the FPGA port numbers. And the next thing we'll do is take a look at the FPGA's schematic using Libero again. So let's close this. Oops. I'm going to close this. Close the IO editor. And we know these port names, which we should be able to find. So let's go to Design Hierarchy, My Custom FPGA Design. Whatever's in bold is what you want to open. All right, here are all the signals. P8 all the way down to P14. It's falling down. And it goes to the cape, P8 all the way to P14. So now jump inside of the cape. And now this is where we're looking. I'm going to start looking at Verilog code. It's not there, so let's go into user HDL source files. Cape. All right. So here they are. Those are the LEDs, 3 through 14. And now let's see, let's take a look for one of them. It's an IO. So it comes out of this block called P8IO pads, where it's named again P814. And somehow this will become the magic. Let's see what they're doing. P8IO pads. So we've got a bidirectional buffer. And it's got these slices here. So this is the pad. Right. The data, output data, whether it's an input or output. And I guess if it's an input, it would be coming out on this pin. So there's the slice 8. Work to the top. What they're doing here. 11s and 10s. I think it's magic of 14. Slice 11 is 14. So it goes to 14, GPIO out 14. Oh, that's nice. What was all that slice 11 about? That's me. Um, 13. Okay, now let's go back to the cape, modular instantiated cape. All right, so here we got GPIO out, GPIO enable. Okay, GPIO to M to F. Remember that. GPIO to M to F. I didn't fully expect that. And not connect it up to anything. GPIO to M to F. Okay, so in this video, we tracked the signals from the LEDs in the schematic through the P8 connector to some level shifters where it's 3.3 volt logic on the P8 LED side and it's 1.8 logic on the FPGA side, into the FPGA's bidirectional pads, through those bidirectional pads back to an assign statement in the cape that allows you to select between the the MSS processors driving the GPIO outputs, and our logic like Blinky or such, and the FPGA gateware driving it, and then continuing on tracking back to we track across back to the MSS, which has the RISC processors in it, and that the RISC processor is enabled to drive the GPIO pins.